of the data science challenge. We'll talk about the different ML modeling techniques. We have regression, which models the relationship between a dependent target and independent predictor variable with one or more independent variables, which helps us to understand how the value of the dependent variable is changing corresponding to the independent variables. We have linear regression, decision trees, support vector regression, lasso regression, random forest, and then we have classification, which are used for predictive modeling problems where input training data is used to predict the probability that future data will fall into one of the predetermined or labeled categories. We have logistic regression, naive Bayes, k-nearest neighbors, decision tree, and support vector machines. Then we have clustering, which is a technique for dividing the population of data points, grouping them into different clusters on the basis of similarity and dissimilarity between them. It helps in determining the intrinsic group among the unlabeled data points. We have affinity propagation, algorithmic clustering, Birch, dbScan, k-means, mini-batch k-means, mean shift optics, and spectral clustering. There's various libraries imported here: Seaborn, PyPlot, NumPy, Pandas, RGB2X, which is color, scalar and preprocessing, which imports standard scalar, and PCA. And then we have a cluster hierarchy and Pearson R coefficient with colors, and it's basically loading the data here, printing out the info, describing the data set, looking for null values, checking unique gender values, and then basic data visualization, top 10 customer age group by gender, comparing between male and female. It's doing more detailed plots, and then it's printing out this KDE plot, which is more detailed, and it's basically showing different clustering methods. Here you can see these points are starting to be more grouped up, and then it's showing annual income versus age by gender in a Seaborn SNS bar plot. And then it's trying to do more clustering later, comparison of age versus annual income by gender. And it's doing correlation, Pearson's correlation between age and spending score, and basically printing out that coefficient here. Annual income and spending score again. Maybe this is a slightly different plot. It has a different Pearson coefficient just based on how the clustering works, as you can see. Again, same thing, also different clustering and Pearson coefficient. I guess it's changing the type of one of the variables here is changing, not sure which one, but it's giving different correlation values. Maybe it's this right here. Anyways, and then we have the comparison of annual income versus spending score for this. And then customer age versus gender, finally ending off with a heat map. And then we have our third kind of example here where it's the second part of clustering, same libraries, data is loaded. It's basically printing out distribution plots, as you can see here, of age, annual income, and spending score. It's doing label and encoding, converting categorical variables to numerical variables by using sklearn and preprocessing, and using label encoder and transforming it with this index, standardizing the values using standard scalar, fitting and transforming, and then doing PCA analysis with the components. And then it's trying to find the optimum number for the cluster using k-means analysis. There's a for loop here with k-means and k-means plus plus, appending certain values for inertia, and then plotting the figure. And then this is the elbow method. It's a very common method. It also put up 4 clusters for the PC analysis using k-means, as you can see here. And then this one tried to do it with 5 clusters for a different PCA. Then we have hierarchical clustering, which makes this Dendogram plot over here. And you can see it comes from the CH library that was imported before. You also have segmentation using age and spending core. There's a score, there's a for loop over here, and it's still doing the elbow method. This one's doing customer segmentation using age and spending score, and then this one's again using income and spending score to basically do the elbow method and look at clusters. It's a bit repetitive, but it's slowly trying to cluster all the data together by using the elbow method again and again. You can see that these points are changing, and that's pretty much everything we're going over today. Thanks for watching.